Hi guys, and welcome to this tutorial. Today we're gonna do activity 3 of page number 128. So, tangencies. We have read already the book with theory. Now we're gonna put in practice what we have learned, and we are gonna start doing these 6 exercises. Sorry, 1, 2, 3, 4, and 5 exercises. And I'm gonna give you a hand. I'm gonna run through it with you to show you how it's done. All right. So what we need today is your bevel and a square, and you also need a compass. Okay. So get your things ready, and we start right now. Okay. I'm gonna get everything ready. I also recommend to you to put some cello tape in the page right in 2 corners so that it doesn't get moved while you're drawing because it's quite important to have a solid support to work. Okay, so let's go with exercise number 1. So it says, draw a circumference with radius r that is tangent to lines S and T. Okay, so we have this exercise. We have 2 lines here, and we want to draw a circumference right there which has radius r. So how do we do this? It's quite simple. What do we know about this? We know that this circumference is at the distance r, the center is at the distance r from the first line, at the same distance r from the second line. So it's quite easy. We only have to create parallel lines to the ones given. In order to create these parallel lines, what we have to do is first we draw a perpendicular line to one of them, get the compass, we take the measurement r, here it is, with the compass, we take it, and once we have it here, we put it there to make a mark in this perpendicular line so that we can draw this parallel line. All right, so let's create this first parallel line. So here we have distance r from here to here. So this line is parallel to line T at the distance of r, which is given. So now we have to do the same procedure with S. So we go to S, create a perpendicular line, and then in this line we're gonna put the same distance, which is r. So we go here and then mark distance r in here. Now it's just a matter of doing another parallel line here at the distance r, parallel to line number S. So where is the center that we're looking for? Right in the intersection is point number O, which is the center of the circumference with radius r given, that is tangent to here and here. So what is left to do? Tangent points, sorry. So what we have to do is we have to get the points where this circumference is touching the lines, which are this and this. So how do we do this? We get the direction of T, we keep the bevel steady in the same position, and we put the square making a V. All right, so you see the V, we make a V. Why? Because these allow us to make parallel lines and perpendicular lines, yeah? So what we do here is we get the direction, get steady the bevel, and create a perpendicular line with the square. Going through point number O, we will get point number A. Same procedure, we get the direction of S, and then we create a perpendicular line to S, going through point number O, and then we go point named B. We have A and B and the center, which is O. It's just a matter of getting the center and connecting with radius r, which is given, points A and B. Yeah, so it should give you something like this: a circumference with radius r given that is tangent to line S and T, and it touches in A and B. Well guys, we're gonna do the second exercise that it says draw two lines that are common internal tangents to the given circumferences. Okay, what we have to do here is, first of all, we need to find which one is the small and the big one. Okay, we're gonna get the radius of the small one and we are gonna put it right after the big one. Yeah, so we got a line here. We put this radius after the other circumference. Yeah, so we're gonna get this, pinch it here, get this dimension. Okay, we have it here, and we're gonna put it next to the point of contact. Yeah, so what we've done is we have gotten the radius of the small one and we have put it right after the big one. So now we can do a new circumference with the center that has a radius which is the addition of the big one plus the small one. So if this is R and this is R, capital R, so here we've put the small r, and the distance from here to here is r plus r. Yeah, we have this circle. The next thing that we have to do is we have to do the line that joins the two centers. We have this line linking the two centers, and we have to find the midpoint. In order to find the midpoint, the procedure, it's known from last year. We have to, with an arbitrary radius, create these segments of these arcs up and below from the two centers. This will give us these two joint points that, connecting them together, will have a line which is perpendicular to the segment that links the two centers, and it goes through the middle point. So this is the middle point. In this middle point, we're gonna call it, this is O1, O2, this is gonna be O3. This middle point, we're gonna pinch with the compass, extend up to one of the radius, and we're gonna draw this circumference. Okay, so this circumference. Okay, after we have done this, we're gonna find the connection points where the first circumference, which is the addition of capital R and R, gets to the circumference that joins the two centers. Yeah, so this is the intersection point and this is the intersection point. Okay, so these intersection points, we're gonna link them with the center of the big one. Yeah, that's it. And then we're gonna do the same in the other side. Okay, so we have it here. The next thing, it's recognize these connection points, which are A and B. These will be the tangent points of the circumference O1 with the line that connects the circumference O2. What do we have to do? We have to create parallel lines to the ones that we have created through the other center. So in order to get the connection point, the tangent point in the other circumference, we're gonna parallel this line here through this center. Okay, we get this line, create a parallel through the other center. That's it. And we have now point named C. All right. So same procedure with this line that connects O1 with B. We're gonna do a parallel through this center. Okay. We do the parallel through the center, and now we have here point D. Okay, so now it's just time to mark the solution. We are going to link point A with C. Here it is. We create this line in a different color just to mark the solution. And we now see that this line, I'm gonna call it S, is tangent to this circumference and to this one in points A and C. And then there's another solution, which is linking B and D. If I create this line, let's call it T, it's a tangent line to this circumference and this circumference in points B and D respectively. Alright, so we got this exercise done. Okay, let's go to exercise number 3. In this one, it says two straight lines that are common external tangents. Okay, so it will be something like this. This and this. We need to get these lines that are tangent. They are not internal as in the other exercise, which were these ones. We need the external ones. The procedure is quite similar. It starts the same way. We need to create, first of all, the line that links the two centers. Yeah? And we need to recognize R and R. Now, what we have to do, instead of adding one to the other, we have to do a subtraction. We need to get the big one and do minus the small one. How do we do this? Well, in geometry, we do additions and subtractions this way. If we put a distance here, which is, for instance, 5, and we need to subtract another distance, which is 2, what we do is we get this with the compass, we put it here, yeah, this distance, and we do a mark like this. So we put 2 here. What will be the result? 3. Yeah? So this is what we're going to do here. We're going to get this distance, R, with the compass. We get it and mark it. Very good. And we're going to put it backwards in here. Yeah? So here, from here to here, we have put this small r distance. So this distance here, from here to here, is big R minus small r. So now we have to draw this circumference. Very good. So let's do it. It's a bit difficult when they are small. Alright. The next thing that we have to do after we have done this is do the midpoint of this segment. Okay, so same procedure as in the other exercise. Get an arbitrary radius, 1, 2, the other center, 3, 4. Alright, the line here, the midpoint, and this midpoint will give us a new circumference that connects the two previous centers. See? Alright, we draw it. Very good. So, now, what do we have here? Now, here we have an intersection of this circumference with the subtraction circumference, which was this one. And these are the points. Yeah? This and this. Well, but these are not points inside this circumference. No, they are not. But what we have to do is link them with the center. We just connect them, this one with this one, extend this line. Wow! Now we have point A. We do the same with the other one, and we get point B. Here it is. Well, to get them in the other side, it's just quite simple. You just have to do parallels. Yeah, but we have to be quite careful, all right? Because we need to do parallel to this one through the center in here, okay, only this part, and then we have C, okay. We get to the other direction, we get this direction, and we do the parallel. Oops, you have to hold steady the bubble in order that it doesn't move. All right, so parallel to the other side, you see, parallel to this one in here, and we get point D. All right, so in order to draw this perpendicular solution, we need to link D and A. Voila, we have this first result. The second one will be C and B. You will link them and we have it already. This is the two straight lines, common external tangents to these two given circumferences. Note that this line has to be parallel to this one because both they are perpendicular to the tangent. As we know in the tangent theory, every tangent line touches in a single point a circumference that is perpendicular to the radius. Okay, so OB is the radius perpendicular to the tangent line because it's tangent in point B. All right, and the same applies to C, D, and A. Okay, very good. Let's go with the next one. Okay, so for this exercise, we have to do a circumference that is going through N and M inside the given circumference and tangent to this one. So, a little bit of theory. If we have this exercise where we have a point here called M, we know for certain that every circumference that is tangent to this one in point M will have its center in this line. Okay, so this one will have the center here, this one will have this center over here, yeah? All the centers will be in this line. So the first thing that we have to do is draw this line, which is here. So the first place to find this center is this line. All right, so we have it here. Next thing, that's another part of the theory that it says that if we want to find the center of a circumference, example like this, and we have 2 points, N and M, the center will be in the perpendicular line that goes through the middle of this segment. All right, so we have to do the middle point here, and in this perpendicular line to the segment that goes through N and M, in this line will be the center, which is here. Yeah. So if we have this N and M, the center of the circumference going through N and M will be in the midpoint, the line that goes through the midpoint and is perpendicular. All right. So we have to do this. Go an arbitrary radius. Get it here, here. Then connect these 2 points, and in this line will be the center of every circumference that goes through N and M. For instance, if we have here N and M, we have this circumference, we have this circumference, we have an infinite number of circumference, but all of them will have its center in this line. Yeah, here, this one is over here. So we have 2 places where this center should be. In the line that connects the original center with M, which is this one, and in the perpendicular line to the segment N and M. So there's only a possible point, which is this O, This is O1, this is O2. O2 is the center of a circumference that goes through N and M and is tangent to the previous circumference given. Okay, we adjust the compass and we can now draw this circumference. And the last exercise, which is this one, is quite simple. We just need to draw a circumference with radius r, which is tangent to this one and also to this line. We have the radius. So the first thing that we have to know is a little bit of theory, that every circumference tangent to a line will have its center in a parallel line to the distance radius, right? Okay, so if we put the radius r here in a parallel, we have the first place of all the centers of all the circumferences that are tangent to this line with the radius r. So the first thing that we're going to do is we get to do a parallel to T at a distance r. Alright, let's do it. We have to do a perpendicular line to do the measurement. We take this distance, yeah, get it in the compass, mark it here, and do the parallel. That's it. This parallel is the first place where this center will be. We need to find another place for this center because it has to be tangent to this one. So if we go through the theory once again, every circumference tangent to another one will have its center at a distance radius, yeah, from the other one. So if we need to find this second circumference, its centers will be at a distance r far above from the other circumference. So where is the place where all these centers are? Look at this. In this circumference. We just need to do a new circumference adding the distance r to the previous one. What we do is we get to a line, a radius, extend the radius, put the distance r, and create this circumference. And this will be the place where all the centers with radius r are located. Alright? So the second condition, we're gonna do it here. We have to do a line right here, and we have to put the distance r. We get it once again, we have it, we put it here, and we mark it here. So this is distance r, and this is distance r, okay? So now we have to do a concentric circumference that goes through this point. All right. And where is the center that we're looking for? It will be in the intersection of this circumference and this one, where it meets the two conditions. First condition, tangent to this one at the distance r, so this one. Second condition, tangent to this one at the distance r. Where is it? Here. Here and here, there's only one point satisfying these two conditions. And now that we have it, we need to find the tangent point. Link it with the center. Here it is, point A, first tangent point. Second tangent point will be in a perpendicular to line through the center. All right, here it is, tangent point B. Now it's just a matter of getting our compass, extending to A or B. It should be the same distance and it should be R, which is given. Very good. We check it before drawing. And now we have the center to draw a circumference with radius R, tangent to the given circumference, this one, and also to line T. Okay, that's it. Very good. So I hope you're doing well, and please submit to my email all your possible doubts, and I will be happy to send you a video or answer you. Alright, bye guys.